So, good evening to one and all. This is Ayyappa Srinivasan MG, Assistant Professor Triple E of St. Mother Teresa Engineering College, handling electric circuit analysis of second semester Triple E. So, in this video, we are going to see about the introductory topics in electric circuit analysis. So, circuit analysis mainly depends on sources. So, the electric circuits have following elements. One is voltage and current source, resistance and inductance. So, first we have to first see all these properties, that is resistance, inductance and capacitance in a very good way. That is, the resistance is nothing but opposition to flow of current. That is, whenever current flows through a conductor, certain thing opposes it. That is called resistance. Now, what we go, that is, next the thing is inductance. Its unit is the unit of resistance is ohms, right? Then the symbol is as shown, right? This is the symbol of resistance. Likewise, inductance, the property of the coil in which change of current produces change in magnetic field and hence voltage across it. See, whenever a current flowing through a particular component changes, the flux will change, and this changing flux will definitely induce an EMF. Such a thing is called inductance. For resistance, the resistance you can find in fan regulator, old regulators, where you can find a brown color thing that is called resistor, and inductor is nothing but a coil. So the coils you can find in transformers, that is 60-70 rupees transformers, that is available in shops or in fan. In fan you can find a coil. That coil is nothing but an example of inductance. The third one is capacitance. The capacitance is nothing but the property by which by the property when two electrodes are separated by a distance, then charges are stored in it. Whenever two electrodes are separated, two plates or two electrodes, whatever may be separated, and voltage is applied across them, then definitely charges will be stored in them, in the surface as well as in between space. In between space, a thing called dielectric will be there, right? So in the dielectric also, charges as well as electric field, electrostatic field will be stored. So this is the symbol of capacitance, its unit is farad. This is the symbol of inductance, its unit is Henry. Now charge. Charge is the fundamental unit of any material. Whenever the charge flows, current is created. So in a case, current is dq by dt, right? This is the fundamental property. And voltage as well as power as well as energy. Voltage is nothing but work done to bring a charge from one point to another. That is called voltage. So, yeah, there is a charge. So, in electrical, you might have heard electrician saying phase and neutral. So, voltage between phase and neutral is 230 volt. What does that mean? The work done to move a charge from phase to neutral through some other thing, say fan or light or some other thing, is 230 volt. It is also defined as work done per unit charge, right? So it is the voltage. Then power and energy. Energy is the capacity of doing any work. Its unit is joules, and power is the product of voltage and current, right? So in circuit theory, the unit of energy is joules, power is what? Watts. In circuit theory, two things are important. One is voltage source as well as current source. The voltage source, is ideal or practical. Usually in physical cases, we find practical voltage source, while the ideal voltage source does not have any resistance. Practical voltage source has a resistance in series to that. So, what is the best physical example of voltage source? A battery, right? Battery has practical resistance, so it is a practical source. Likewise, we have another source under consideration, that is called current source. What is a current source? So the current source is nothing but a source from which current flows enormously. It is physically not available, but voltage sources are usually taken as current source. In practical classes you will find that. So a current source which does not have any resistance parallel to that is called as ideal current source. Otherwise, if it has resistance, it is practical current source. This is independent source. Now we are going to see dependent source. For this practical example, various electronic devices will be there. So we can see in later things. So just know that is there are four types of sources: voltage controlled voltage source, current controlled current source, voltage controlled current source, current controlled voltage source. Just find these things. Then we are going to study something that is relevant to the unit 1, node mesh loop. Node means a point where more than one electrical elements join is called as node. Mesh is any closed path. Mesh is a loop that does not contain another loop in it. Mesh is only one closed path, where loop is many. It is also, mesh is a closed path which does not have any other closed path inside it. But loop is a closed path which may have another closed path too. For example, I am showing in the thing, ABED is a mesh, while ABCFED is a loop, because ABCFED has one another mesh in it, ABED. ABCFED is a loop because it has one another closed path in it. That is, the one another closed path is nothing but ABED. So it is an ABED is a mesh, ABCFED is a loop. So kindly understand the difference between mesh and loop. Now let us go for main thing, that is called Ohm's law. The Ohm's law is nothing but, it states that, Ohm's law states that under constant temperature, the potential difference current flowing through the conductor, say a conductor carries current in a constant temperature, means then the current flowing through it will be directly proportional to voltage across it. The current is I, current is given by I, voltage is given by V. So current is directly proportional to voltage across the conductor, and current is inversely proportional to resistance of the circuit. Current I is inversely proportional to 1 by R resistance. Current I is directly proportional to voltage V. So I is equal to V by R, or V is equal to IR. The Ohm's law has certain limitation. One is, the main thing is, it is only applicable for constant temperature, where that is, it is not applicable to fan winding, because in fan winding, as the current flows through it, the temperature rises in the winding, and it does not hold good for fan winding. The temperature changes with respect to time. That is, as the current continues to flow through it, and the temperature is not constant. Further, it is applicable only to linear element such as resistance only. For inductance and capacitance, it does not hold good. So, let us consider the next one is Kirchhoff's voltage law. A Kirchhoff's voltage law states that algebraic sum of voltages in a closed path is zero. Right? Usually, it is stated in another way as sum of voltage rise in a closed path is equal to sum of voltage drop. Voltage rise is nothing but voltage across the voltage sources, right? And voltage drop is nothing but voltage across the element such as resistance. So, if we add the voltages across the resistance, that is voltage drops, it will be the sum of voltage rise, that is across the battery or voltage source, right? The next one is the next one that comes into the, we have certain problem. So certain problem, we will see the problem, that is 10 coulombs of charge flow through a given point in 2 seconds. How many amperes of current flowing through it? So 10 coulombs of charge flows through a circuit, right? 10 coulombs of charge flow through a conductor in 2 seconds, right? So what is the current? That is coulombs is given by Q 10 and current is given by I and time is given by T, that is 2. So 10 coulomb, Q is equal to 10, for time 2 seconds. So 10 by 2 is equal to 5 ampere. Now let us also consider another problem using KVL, right? 6 volt voltage source has an internal resistance of 8 ohm. Find the voltage experienced by a load of 3 ohm. That is 2 ohm resistance is there already in the voltage source and 3 ohm resistance is connected to it. So voltage rise is 6 volt. Voltage drop is current through the voltage across 2 and 3 ohm. Voltage drop across 2 ohm is I into 2 by Ohm's law and 3 into I by Ohm's law. So 2I plus 3I is equal to 5I. That is 1.2 ampere is the current flowing. It is the current flowing through it. The next one we are going to see is series and parallel connected circuit as well as Kirchhoff's current law, that we will see in the next video. Okay, thank you.